Okay, so why we are going to these concepts? Because as a part of the embedded, we need to understand the basic components about the resistor, the capacitor, all those things we should be aware. Okay, so and how we should understand those things. So we need to understand from the basic level and how that is integrated those resistors or capacitor or the FET such things in the real world. We need to know. Okay, so if- how, because if you see the resistor have a different variants, right? So it have the mid variant or the low level resistors, like 1 ohm resistor to the thousands of kilo ohm resistors. Each and every resistor, it has specifically the benefits, and similarly the capacitor or inductor. So this is used for the enabling of the voltages and fluctuating of making the reduce of the filters. So each and every component, it plays very beneficial role in the um, when it is interconnected with the circuit diagram. Okay, so actually we saw that previously, like there is a one application in the current, and how if it is interface to the voltage at the ground, so how that will be varied. Because it will be in a constant where the voltage will be given and it is given to the ground. In case the resistor and the I need to find out the resistor, how it will be restricted. So if example, if we see there is a the current electrons are flowing, and we have the resistor here, so what it is doing, it is restricting some flow of current. Okay, if the resistor is not there here, okay, let assume that there is no resistor. So simply I connected here with uh, the wire. Okay, so what will happens is, so it will directly so means whatever the electrons it flows, so that will be conserved. In case if the resistor is placed in between, so it will restricts the flow of current. Okay, so like it kind of a filter, it will be allowed. Okay, so so what is the voltage it is driving, so that will be applied, and remaining it will be holded. Okay, so that is our resistor. And even the capacitor, so capacitor is, it is a kind of the charging and discharging will be happening. Okay, so this is a like a capacitor. So whenever you need a charger, here we have the capacitor. So it always have a plus to minus. Okay, so always electrons flow from positive to negative. Okay, so you are aware for the wires. So whenever we are saying that I need a 5 voltage or 10 voltage power supply or 12 volts power supply, so it's nothing but the pressure that we are pushing into the wire. Okay, so here, so if someone asks about the voltage, we have some definitions we should give. But for understanding that and remembering of that definition, so we should always need to know there is a some pressure it will be passing in the wire. And coming to the current, so coming to the current, it will be the part of the width or the length, or the size that occupied by the canal, so to flow of the water, so that will be defined as a current. And coming to the resistor, so resistor is, it's a part of the sand that present in the wall. Okay, so here it's a the flow of water will be there. So whenever the you need to reduce the pressure, or you need to make slow down, or some moment should be reduced within the canal, so the resistance will be placed like that. So here the sand is nothing but the resistance, so that we are obstructing it. Okay, so you are understood about the basic of voltage, how it will be act in the wire. It's very important. You should be proactive and give response. Anil Vardhan Chakravarti. So getting right.
Yeah, getting
Yes, sir.
So now it is a, like voltage is nothing but the pressure it is acting in the wire, and the current is nothing but the size of the panel or the wall, or the means in terms of water I'm saying. So it's similarly the wire width. Okay, so and resistor, so it is a part of the restrictions. So it's like a resistor. Okay, so the definition, the any electron or like we are using as a part of a home, we'll discuss always current voltage. Like when we are using the technically, we'll always pay that voltage. And specifically, when we discuss normally in home and all, we'll always say that, oh, is there a current or not? So current is nothing but how much volume that we are using it. Okay. So, and these are very three important components specifically to know, and moreover the definition to understand about the terminologies. Okay. So the voltage, current, and resistance. So voltage is like the pressure that pushes the water through the wash. It is so for that we have the volt units is the volts. Okay, so voltage it's having units volts, and the current. So current is the diameter of the hose, and it is wider. The more water will flow through it. Okay, so it is a measure. The measurement, the measuring moment means whatever the units we say for the current, it is a amps. And next for the resistor, so it is like the sand in the house. So that slow down the water flow. It is uh, units have a the ohms. So these are very three important components for the electricity. And next, coming to the how this relation is combined whenever we talk the water or the current or the resistor. So how this relation is formed? So it have a formula like we are familiar with this. V equals to IR. V is voltage, I is current, R is resistor. So whenever imagine there is a tap here, okay. So there we have the pump. So from the top, like you are going to adjust. The water flow with the help of the pump, and once the water is driven, so the sand will decide whether the water is should be allowed further, or it should be blocked further. So the sand is a part. So let's consider the same example in terms of electricity here. So like we have a battery and the bulb. Okay, so whatever the voltage you are giving from the battery, that will be supplied to the bulb. Okay, so whatever the supply is happening from the voltage to the bulb, it is a part of the current. Okay, and the bulb is it is utilizing some um, energy. Okay, so let's make it our understanding. It's utilizing or the filtering. It is a part. Some abstraction will be there. So that abstraction is that resistor. So the V I R. So this is very simple diagram to understand. If sometimes, because when we go into the experience way, so sometimes they may ask you like, can you give me the simple circuit diagram for voltage and current and relation resistance? So you can give this basic diagram. Okay, so these are the voltage and current resistors that are related. So if you change any one of them, okay, so means suppose the resistor is not there, what will happen? Whatever the voltage you are giving, so it will completely it will be in the circuit, so that will be flowed. Okay, so it is derived a small relation, the formula V equals to IR. So just we understood about how the water and the sand will place and how the pressure will be formed. So that is a part of the understanding of the electricity that we following. And coming to the other concept, so the important concept is about AC current and DC current. So what is AC and DC current? So whatever the AC is a alternating current, and DC is the the single direction mean constant power supply that we are giving it. Okay. So now coming to the one important questions. So whatever we have the televisions and laptops and mobiles, which type of voltage we'll use? Whether AC voltage or DC voltage? DC current. Which current? But current is like a flowing, right? So the it is a part of the direction where it will be started and ending from the positive to negative terminal. So here, whenever we are giving the current, so for the TVs or the mobiles, the TV charge, it is a part of a DC. Okay, so and coming to the AC, it will be in a continuous sinusoidal waveform. So there will be a front and backward positives will be happening, and like the fluctuations will be happening. That is a part of a AC current. Okay, DC is similar to the normal flow of water in a house. It flows in one direction from source to end, and AC is like a water flowing back and forth within the hose. So it will be also decided that by the time. So whatever like we are um, transferring, right, the current. So that current should be with respect to that time. How much flow will be happening? What is the time it is taking? So that will be decided by that time. Okay, so the water here, the AC, it will be whatever the waveforms it will be generated, it will be in the sinusoidal waveform. So in terms of the water, if we decide, so the waves will be in a continuous. Okay, so like up and downs, falling will be rising, will be there. So and we are familiar with the batteries. So whatever the batteries which we talk, so it will be a part of a one storage where the DC power will be occupied. Means whatever the with the help of the DC current, it will be charged, and so the batteries usually have the uh, watts, kilowatts, right? So watts and kilowatts. It is a power. So power is specifically it is a combination of the voltage and current. How much it charging? Okay, so it will be included from so many divisions. So like watts to kilowatts. Okay, so if we observe about some of the chargers which we have, like 25 kilowatts batteries or 100 kilowatts batteries, so we usually say that that is the power it able to do such a faster. And the transformers, so transformers is like it is a part of the conversions will be happening. Okay, so it's like a holding your thumb and just what how much the current you require, that only you are transferring, remaining you are not able to transfer. It is a part of just there is a tap of water. So in that you are holding your hand and allowing just how much you are able to um, divide the partition of the current and with the from the transformer, and whatever you require, so that only it will be allowed from the transformers. Okay, so just here I given some of examples, so it's related to the water combination. How like with the help of this you were able to understand. So the water volume is the power, and the pressure is like the voltage, and the current is the diameter. Okay, so that's how the relation we discussed, and the resistance is like a sand. Okay, so now coming to the, we need to discuss about the power. So power is like the volume of water is flowing from the hose. Okay, so specifically it is a relation with the pressure. So that is formed inside the wiring or the whatever the water we are going to discuss, right? So in terms of hose. Okay, so as how these units will be, it is measured in the terms of watts. Okay, power is measured in the terms of watts. So kilowatts means it will be the 1,000 watts, and 1 megawatts, so it will be differ. Okay, so because if we remember whatever the voltage near to the dams, the current they are generating, right, it should be a milliwatts, and megawatts should be required, okay, for generating the complete if you take one small village or a city, the utilization of the power will be more. Okay, so the supply of the current and power also it's required more in that areas. So for this they need to generate more also, so that units will be measured in the terms of the power. Okay, so and energy is measured in the volume of the water that has flowing through the hose over a period of time. Okay, whether it should be given within 5 seconds, the water should be empty, like within 1 hour I need to empty the water. So it's like the same way, like what is the current you should be distributed within 5 minutes or 2 minutes, so that will be a part of energy. So as we know, the understanding of these electrons is specifically the smartphones and the cars. Okay, like we are using every day the components related to the electronics. So everywhere it is a combination of this resistor, capacitor, and transistors will be there. Okay, what is electronics? So electronics is the study and application of the flow of electrons through the material. Is it clear? If someone asks you about what is electronics, you can able to give this definition for them.
Yes, sir.
Yeah, and because we should explain in terms of technically, so it is a part of flow of electrons through the materials. Okay, and next, how does electrons works? So electrons works whenever the flow of electrons through the material or some device should be there, right? Some wire or some pin or some port configuration should be required for transferring of the uh, data. Similarly, the data here, it carries the information. Okay, so in that okay, so whether it will be the wire or wireless, anything, there will be the flow of electrons. So the flow can be controlled and manipulated with how this data or the flow will be controlled with the help of the circuits only. Is it clear? So on the devices. So now coming to the definition of the what is a voltage. Voltage is the electric potential difference or electrical pressure that driven the flow of electric current in a circuit. This is the main definition you should aware. Okay, so if someone asks you what is a voltage, it is the electrical pressure that drives the flow of electric current in a circuit. You write down the definition. So voltage is the electrical pressure that drives the flow of electric current in a circuit. So that is the pressure as we discussed, right? So voltage is nothing but a pressure. So here the voltage is the electrical pressure. Okay, this is a very important definition. If someone asks you, you should be familiar. Okay, and voltage is the pressure from the, so where this pressure is getting, so it is generating from the power source, electrical circuit power source. The power source is nothing but the battery or any generator, like where the uh, like steam engines, they will generate the power, and even the electrical near to the dams, they will generate the water. From the water they will use to generate the power. So it is a part of the power source where the main power will be supplied, whether from the wind energy, whether from the water energy. So that will be a part of a power source. So what exactly will happen? So with the help of the pressure, it will be pushes, the pressure will be formed. So based upon the pressure, the electrons will start moving from the wherever the source to destination. Okay. So if I take example of light and battery, so how whenever we power on the switch, the bulb will glow. Means so the power is supplying to the battery, so then only it will be turned on. If there is no power supply on the battery, it will be turned off. Is it clear? So that is a V equals to IR. The relation of this voltage is V equals to IR. Okay, next we need to understand about the circuit. So if someone asks you what is a circuit, so it is a circuit is a closed loop or the path that allows electricity to flow. Okay, so if you take the switch and bulb, we used to connect with the help of the wire, right? So that is a part of a circuit. So here a circuit is a closed loop or the path that allow the electricity to flow. Okay, so it enables the operation of electrical component or the devices. So whatever the component, electrical components we discuss, it's about the bulbs or the switches or the wires. So that are the components and the devices. Circuits are designed to, what is the purpose of the circuit? So because we need to enable or disable, it should be controlled. Okay, so with the help of the circuit only we are able to control it. Okay, because whenever we power on, the electrons will be starts flowing in the wire and enable the bulb to glow. If not, it will be stopped, means electrons are stopped. So there are three kinds of circuits. So closed loop circuit. Closed loop circuit is the circuit in which the path is fully completed. Okay, means from the bulb to wire. So like the bulb will be there and the switch will be there. So there will in between we are connecting the wire. Again from bulb to switch, you have one more wire. So it is a kind of a looping completely. It will be a closed loop circuit and open loop circuit. So if in case like if you between the switch and the bulb, the wire is connected. Another side, the wire is not necessary. So that will be open circuit. And short circuit, like in case you need to make the connection of the fan connection and light connection to the one single switch. So just we are bypassing it, right? So that will be means just we are connecting it to the other one. So that's fine. Like it can work for two, one LED, so one bulb and one fan. It can we can control with the help of single switch. In case if it is a short circuit is happened for the switch wire, what will happen? The entire the bulb, fan, LED, anything that we connected, it will be go away. So if in that case, what should we do? So similarly, like whatever the voltage or the current we are giving for the devices, it comes to the mobile or it comes to the televisions or the electronic components wherever we are using. So if there is a short circuit is happen, then it's there is no current will be passing for the devices. So means whatever the short circuit is happened, the entire power will be distributed to the within the circuit. So that's how the circuits are very important always. We should be connected end to end, and it should be with the without any disturbance and without other load. It should be established. This is the circuit you should be aware. Okay. Is it clear? The types of circuit we have um, serial circuit and parallel circuit. Okay, so circuits we can connect three levels, but it have different ways. Whether we are connecting in a series circuit or parallel circuit is very important. Okay, so whenever you are connecting the bulb or the fan, or any other components in a series way, if one is not working, the other devices also it won't work. So in case if it is a parallel circuit, if bulb is not working, the other bulb can work or other fan which we are connected, it can work. So we need to ensure that whether the circuit should be in a series circuit or the parallel circuit. So there are two types of circuits. So that that is if one component is not working, the entire system get be problem. And parallel circuit. So if the one component is not working, the other component can be controlled and activated. So in case the open circuit is similarly like power supply and the bulb, so it will be a open circuit. It will be we are able to operate with the help of the switch. Whenever we require, we can close. If closed means the switch can be on, the entire looping will be there. So the current will flow from positive to negative one, like supply to bulb and bulb to supply. That will be then a closed loop system. Okay, that will be the continuous flow will be there. So in case if it is a open means whenever the switch is open, that time there is no flow. So here because of the break, the positive terminal to negative, the electrons are stopped. So that is a open circuit, closed circuit. So this is very important to understand how the circuits are enabled and disabled, and what is this open circuit we are doing, what exactly we are doing with the closed circuit. Next, we need to understand about the power. So what exactly the power? So it is a combination of the voltage and current. So, okay. So the whatever the voltage and the current uh, measures the power. Okay. So power refers to the rate at which energy is transferring or converts within a system. So the units is watts. So whatever the energy we are talking, right? So that is a part of the power. So like how this can be measured. So how much work it able to do. So what is the energy it is utilized for doing of some work. Okay, so for 1 minute transferring of current, what is the utilization, what is what is the utilization it made during 1 hour or one day. So that will be measured as a part of the power. Okay, so the relation of this is P equals to V into I. So here the power, voltage, and current is the formula. And we need to discuss about the current. So current is we know that it is a flow of electrons in a circuit.